Hello friends, today we are going to discuss part 1 of multiplexing, that is time division multiplexing. As we have seen, there are three basic categories of multiplexing such as frequency division multiplexing, wavelength division multiplexing and time division multiplexing. In previous lecture, we have discussed frequency division multiplexing, which is analog in nature, wavelength division multiplexing, which is also analog in nature. Now, in this today's lecture, we are going to discuss time division multiplexing. For that, we have to consider this is in digital in nature. So, first, time division multiplexing is a digital type of multiplexing technique for combining several low data rate channels into one high data rate channel. As we have seen in the diagram, time division multiplexing. This is the conceptual view of time division multiplexing. Here, same link is used as in FDM. The link is shown section by time rather than frequency. That is, link is divided into time duration instead of frequency. Here, in this figure, portions of the signals 1, 2, 3, 4 occupies the link sequentially. Here, all the data in a message from source 1 always go to one specific destination 1, 2, 3 or 4. The delivery is fixed and not varying as like switching. So, in digital multiplexing technique, digital data from different sources are combined into one time-shared link. This does not mean that the sources cannot produce analog data. Analog data can be sampled, changed to digital data, and then multiplexed by using TDM. Can divide time division multiplexing into two different schemes such as synchronous time division multiplexing and statistical time division multiplexing. So in this lecture, we discuss some points regarding to synchronous time division multiplexing. In synchronous time division multiplexing, each input connection has an allotment in the output even if it is not sending any data. Data flow of each input connection in synchronous time division multiplexing is divided into units, where each input occupies one input time slot. A unit can be one bit, one character or one block of data. Next, each input unit becomes one output unit and occupies one output time slot. The duration of an output time slot is n times shorter than the duration of input time slot. If an input time slot is Ts, then output time slot is T by n seconds, when n is the number of connections. That means a unit in the output connection has a shorter duration, then it travels faster. In the given figure, synchronous time division multiplexing is shown where n is the number of connections is equal to 3. In synchronous TDM, a round of data units from each input connection is collected into a frame. If we have n connections when frame is divided into n time slots and one slot is allotted for each unit. As shown in the figure, the data rate of link is 3 times the data rate of the connection. Here from 3 sources, time is divided into t second. The duration of a unit on a connection is 3 times that of the time slot. That is the duration of a unit on the link. We represent that the data prior to multiplexing as 3 times the size of the data after multiplexing. That means each unit is 3 times longer in the duration before multiplexing than after. Time slots are grouped into frames, and a frame consists of one complete cycle of time slots with one slot dedicated to each sending device. With a system with n input lines, each frame has n slots, with each slot allocated to carrying data from a specific input line. In this way, in synchronous TDM, the data rate of the link is n times faster. The unit duration is n times shorter. In this way, in this lecture, we discuss synchronous time division multiplexing. Okay, thank you.